Now that we have calculated the part A, where the child B moves 0.05 meter away from the pivot, and we know that it would move, the whole pivot will move clockwise 765 Newton meter, is greater than 720, which we solved part A. Now moving to part B. Part B is child A puts on a backpack and the seesaw now balances. So the keywords are balances. Calculate the mass of backpack. So if you have to calculate M, what is M? Um, the, so we did something similar in the beginning where before the child B moves 0.05 meter or further away from pivot, it was balanced. It means it was initially balanced, which it means that there was amount of force being applied here was the same as amount of force being applied here, or the momentum being applied here was equal to the momentum being applied here. I apologize, it's not force, it is the momentum. The momentum being applied here and the momentum here is the same previously until the child B moves there. Now the child A puts a backpack. So the child B has moved 0.85 meter away from pivot, and the child B puts a backpack on. So we got to calculate the mass of that backpack. Moving on from there, so it means that for a balanced, what does balance mean here? Balanced. For it to be balanced, the anti-clockwise anti-clockwise moment equal to clockwise moment. So anti-clockwise moment equal to, important part is the equal to a clockwise moment. Let's look into the child A's side. So child A's side. What's child A's side? The child A's momentum is a moment. Let's calculate the moment. I apologize. I keep saying moment and momentum interchangeably, which it is not correct. It should be moment. Moment anti-clockwise. We know that the child A was moving anti-clockwise, right? And this was child B was clockwise. It was moving this way. This was moving that way. That's why. So child A side anti-clockwise. All right. Child A side moment is 450 Newton multiplied by 1.6 meter is equal to 720 Newton meter. We know that. And we want to calculate the backpack. So backpack moment when the child puts the backpack on. The backpack's moment is equal to weight of backpack multiplied by 1.6 meter. So do you agree that I can take the liberty to name the weight of backpack as M? I'll assign M. So do you agree that I can write M multiplied by 1.6 meter is equal to backpack's moment. Um, Moment. All right, that's the child A's side. So what about child B's side? Child B's side is clockwise, right? They put child B moment. We gotta calculate child B's moment. Child B's moment is 900 Newton multiplied by 0.85 meter, where we calculate previously. We know that 765 Newton meter is on child B's. When we write the balanced equation here, we have to write the uh, anti-clockwise moment equal to the clockwise moment because it is balanced, so it's equal to each other. Therefore, now I will write I'll write the balance equation where it is 720, which is the child back the moments on child's A side, 720 plus the weight of backpack. The weight of backpack multiplied by 1.6. So I can write M, which I allocated M here, plus 1.6 meter is equal to 765. Where does that 765 comes? That's the moment from the child B's side. I hope it is clear until here. So what we did, we just wrote the balanced equation here, where it is the moment plus the backpack's moment. So there's a moment of child and there's a moment of backpack. So if you could imagine, if you put a backpack on um, on yourself and sit on a seesaw, you'll have a different moment, and your backpack will have a different moment. Therefore, both of that is equal to 765. How do we know it is equal to 765? Because because the question says that now the seesaw is balanced. Balanced means this mathematically. Therefore, let's calculate this. Let's try to solve. Let's solve this one then. M. Can I write M multiplied by 1.6 equal to 765? We'll send this to the left side. It is minus 720. What would be our answer? 45. 765 take 720 would be 45. Weight of the backpack, which is M multiplied by 1.6. So M is equal to 45 divided by 1.6. What is the mass? So here we are getting M is equal to, what's M? 45 divided by 1.6, gonna be 28.125 Newton. Yeah. Wait, we are after the mass. However, what we got here is Newton. How did we get Newton? Question mark. How did we get a Newton here? If you look closely, 765 and 765, 720, both of them, the units are units are Newton meter. When you put in 1.6 is meter. If you look into here, it is Newton meter. This is the units. Here, purely, I'm writing this in a different color so that you can know I'm talking about units. Newton meter. Newton meter divided by meter. So this meter gets cancelled with meter. We have only Newton here. But we were not after a force, which is Newton. We were after we were after the weight of it. So we know that F is equal to mg. So mass is so from this formula F is equal to mg, where mass is equal to what? Um, F, which is the force, divided by g. And if we assume g is equal to 10 here, we can get 28.125 Newton divided by 10, which is 2.8 kilograms. So the weight of backpack is backpack is 2.8 kilograms. Or if you're using 9.8, you will be getting, if you're using g is equal to 9.8, you'll be getting 2.87, which is almost the same kilograms. It's 2.81. So that's the weight of your backpack. Let me know if you have any questions.